Using the ratio test to see whether or not a series converges or diverges. What do I have? I got this guy. So the ratio test, that's where we're looking at the limit of the next term divided by the term where you're at. What's this? Let me write it explicitly. Oh, you're so explicit. We're looking at the an plus 1 term. That's why I put an n plus 1 everywhere I saw an n. Divided by the an term. That's that in pink. Some of you may have heard that rhyme, that hum, that hymn. Dividing by the fraction's the same as multiplying by the reciprocal. And you probably just started here anyway. Anyways, they fight! When I fight the 1.1, I have 1.1 on the top and annihilation down there in that denominator. And they fight! The minus ones, there's 1 left up on top. And then, can I just cancel out that end of the fourth and the end of the fourth on the bottom? No! Nobody would ever do that. And then, I'm going to bust it, absolutely, into 2 absolute values. Because minus 1 times 1.1 is minus 1. But what's the absolute value of minus 1.1? It's 1.1. I'm just going to write that out front and make that the limit. But we're dealing with n's that are bigger than 1, so n to the fourth is never going to be negative, nor is n plus 1 to the fourth. I'm going to get rid of those absolute values and expand it using the binomial expansion. That's how I'm up here. Yeah. And that denominator multiplies out to be n to the fourth plus 4, n to the third plus 6, n squared plus n, 4n plus 1. Church. What are we doing? We're running the limit, so I divide top and bottom by n to the fourth. I'll get that in a second. But when I do that, I get this. Because it's official. Then we run that limit. That goes to 0, that goes to 0, that goes to 0. It's like Oprah's here. You get a 0, you get a 0, you go to 0. So I'm left with 1.1 times 1, which is 1.1. Not a lot, but a little bit bigger than 1. Because it's any magnitude bigger than 1. By the, which test are we using? Ratio. This series, OG series, what's it do? It diverges. And it's all over but the box and flower.